Welcome to Module 10, Automatic Scaling and Monitoring. This module will address the following topics: Elastic Load Balancing, Amazon CloudWatch, and Amazon EC2 Autoscaling. As you will learn, these three services work well individually, but together they become more powerful and increase the control and flexibility over how your applications handle customer demand. In addition to the topics covered in this module, there are several resources available to further your understanding. This includes an Elastic Load Balancing activity and a CloudWatch activity, as well as a lab where you use Amazon EC2 Autoscaling, Elastic Load Balancing, and Amazon CloudWatch together to create a dynamically scalable architecture, and finally, a knowledge check that you will use to test your understanding of the key concepts covered in this module. After completing this module, you should be able to indicate how to distribute traffic across Amazon EC2 instances by using Elastic Load Balancing. You should be able to explain how Amazon EC2 Autoscaling launches and releases servers in response to workload changes. You should be able to identify how Amazon CloudWatch enables you to monitor AWS resources and applications in real time. You should be able to perform scaling and load balancing tasks to improve an architecture. Let's get started. This video will cover Elastic Load Balancing. Modern high-traffic websites must serve hundreds of thousands, if not millions, of concurrent requests from users or clients, and then return the correct text, images, video, or application data in a fast and reliable manner. To meet these high-volume demands, additional servers are generally required. Elastic Load Balancing is an AWS service that distributes incoming application or network traffic across multiple targets, such as EC2 instances, containers, IP addresses, and Lambda functions, in a single availability zone or across multiple availability zones. Elastic Load Balancing scales your load balancer as traffic to your application changes over time. It can automatically scale to most workloads. There are three types of Elastic Load Balancers, such as an Application Load Balancer, which operates at the application level, or layer 7, of the OSI model. It routes traffic to targets based on content of the request. It is ideal for advanced load balancing of HTTP and HTTPS traffic. An Application Load Balancer provides advanced request routing that is targeted at delivery of modern application architectures, including microservices and container-based applications. An Application Load Balancer simplifies and improves the security of your application by ensuring that the latest secure sockets layer and transport security layer ciphers and protocols are used at all times. Additionally, a Network Load Balancer operates the network transport level, or layer 4, of the OSI model, routing connections to targets based on IP protocol data. It works well for load balancing both TCP and UDP traffic. A network load balancer is capable of handling millions of requests per second while maintaining ultra-low latencies. A network load balancer is optimized to handle sudden and volatile network traffic patterns. Finally, a classic load balancer provides basic load balancing across multiple EC2 instances, and it operates at both the application level and network transport level. A classic load balancer supports the load balancing of applications that use HTTP, HTTPS, TCP, and SSL protocols. The classic load balancer is an older implementation, and when possible, AWS recommends that you use a dedicated application load balancer or a network load balancer. A load balancer accepts incoming traffic from clients and routes requests to its registered targets in one or more availability zones. You configure your load balancer to accept incoming traffic by specifying one or more listeners. A listener is a process that checks for connection requests. It is configured with a protocol like HTTP and a port number such as port 80. Similarly, it is configured with a protocol and a port number for connections from the load balancers to the targets. You can also configure your load balancer to perform health checks, which are used to monitor the health of the registered targets so that the load balancer only sends requests to the healthy instances. When the load balancer detects an unhealthy target, it stops routing traffic to that target. It then resumes routing traffic to that target when it detects that the target is healthy again. There is a key difference in how the load balancer types are configured. With an application and network load balancer, you register targets in target groups and route traffic to the target groups. With classic load balancers, you register instances with the load balancer. There are many elastic load balancing use cases. Let's consider the main ones. First, you can use elastic load balancing to achieve high availability and better fault tolerance for your applications. Elastic load balancing balances traffic across healthy targets in multiple availability zones. If one or more of your targets is in a single availability zone and unhealthy, elastic load balancing will route target traffic to healthy targets in other availability zones. After the targets return to a healthy state, load balancing will automatically resume traffic to them. Next, there's an enhanced container support for elastic load balancing, so you can use a load balancer to automatically load balance your containerized applications across multiple ports on the same EC2 instance. You can also take advantage of deep integration with Amazon Elastic Container Service, which provides a fully managed container offering. You only need to register a service with a load balancer, and Amazon ECS transparently manages registration and deregistration of the Docker containers. The load balancer automatically detects the port and dynamically reconfigures itself. To learn more about elastic load balancing use cases, visit the AWS website. There are a few ways that you can monitor your load balancers, analyze traffic patterns, and troubleshoot issues with your load balancers and targets. One way is to use Amazon CloudWatch metrics. Elastic load balancing publishes data points to Amazon CloudWatch for your load balancers and your targets. CloudWatch enables you to retrieve statistics about those data points as an ordered set of time series data, known as metrics. You can use metrics to verify that your system is performing as expected. For example, you can create a CloudWatch alarm to monitor specified metric and initiate an action, such as sending a notification to an email address. If the metric goes outside of what you consider is acceptable, it can then send that message. You can also use access logs to capture detailed information about the requests that were made to your load balancer and store them as a log file in Amazon S3. You can also use these access logs to analyze traffic patterns and to troubleshoot issues with your targets or backend applications. Finally, you can use AWS CloudTrail to capture detailed information about the calls that were made to the Elastic Load Balancing API and store them as log files in Amazon S3. You can use these CloudTrail logs to determine who made the call, what calls were made, when the call was made, the source IP address of where the call came from, and so on. Thanks for watching. We'll see you in the next video. Welcome. This video will cover Amazon CloudWatch. To use AWS efficiently, you need insight into your AWS resources. For example, you might want to know when you should launch more Amazon EC2 instances, or maybe if your application's performance or availability is being affected by the lack of sufficient capacity. You might also want to know how much your infrastructure is actually being used. But how do you capture this information? To answer these questions, you capture information with Amazon CloudWatch. Amazon CloudWatch is a monitoring and observability service that is built for DevOps engineers, developers, site reliability engineers, and IT managers. CloudWatch monitors your AWS resources and the applications that you run on AWS in real time. You can use CloudWatch to collect and track metrics, which are variables that you can measure for your resources and applications. You can create an alarm to monitor any Amazon CloudWatch metric in your account and use the alarm to automatically send a notification to Amazon Simple Notification Service or Amazon SNS, or perform an Amazon EC2 auto-scaling action or an EC2 action directly. For example, you can create alarms on EC2 instance CPU utilization, elastic load balancing request latency, Amazon DynamoDB table throughput, Amazon Simple Queue Service queue length, or even charges on your AWS bill. You can also create an alarm on custom metrics that you are specifying for your own applications or infrastructure. You can also use Amazon CloudWatch events to define rules that match incoming events or changes in your AWS environment and route them to targets for processing. Targets can include Amazon EC2 instances, AWS Lambda functions, Kinesis streams, Amazon ECS tasks, step functions, state machines, Amazon SNS topics, Amazon SQS queues, and built-in targets within CloudWatch events. CloudWatch events becomes aware of operational changes as they occur and respond to these changes in order to take corrective actions as necessary. With Amazon CloudWatch, you gain system-wide visibility into resource utilization, application performance, and operational health. There is no upfront commitment or minimum fee. You simply pay for what you use. You can create a CloudWatch alarm based on a static threshold, an anomaly detection, or a metric math expression. When you create an alarm based on a static threshold, you choose a CloudWatch metric for the alarm and the threshold for that metric. The alarm state is triggered when the metric breaches the threshold for the specified number of evaluation periods. Let's look at some of the things you must specify when you create an alarm based on a static threshold. The namespace contains CloudWatch metric that you want, for example, AWS EC2. The metric is the variable that you want to measure, for example, CPU utilization. A statistic can be an average or sum, minimum or maximum sample count, a predefined percentile, or even a custom percentile. A period is the evaluation period for the alarm. When the alarm is evaluated, each period is aggregated into one data point. When you specify the conditions for a static threshold, you specify whenever the metric is greater or equal to, lower or equal to, or lower than the threshold value that you specified. You can also specify additional configuration information, which includes the number of data points within the evaluation period that must be breached to trigger the alarm, and how CloudWatch should treat missing data when it evaluates the alarm. Finally, you must specify the action that you want CloudWatch to take. You can choose to send a notification to Amazon SNS topics, or to perform an Amazon EC2 auto-scaling action, or even Amazon EC2 actions directly. Thank you for watching. We'll see you in the next video.
Welcome. This video will cover Amazon EC2 auto-scaling. Scaling is the ability to increase or decrease the compute capacity of your application. To understand why automatic scaling is important, consider this example of a workload that has varying capacity requirements throughout the week. You provision capacity to meet your highest demand, which occurs on Wednesday. If you provision capacity this way, then you're running resources that will be underutilized most days of the week. With this option, your costs are not optimized. Another option is to allocate less capacity to reduce costs. However, in this situation, you are under capacity on certain days. Automatic capacity scaling is necessary to support the fluctuating demands for service. Without scaling, your application could underperform or potentially even become unavailable for your users. In the cloud, computing power is a programmatic resource. This means you can take a flexible approach to scaling. Amazon EC2 Autoscaling is an AWS service that helps you maintain application availability and enables you to automatically add or remove EC2 instances according to conditions that you define. You can use the fleet management features of EC2 Autoscaling to maintain the health and availability of your fleet. Amazon EC2 Autoscaling provides several ways to adjust scaling to best meet the needs of your application. You can add or remove EC2 instances manually, on a schedule, in response to changing demand, or in a combination with AWS Autoscaling for predictive scaling. Dynamic scaling and predictive scaling can be used together to scale even faster. Automatic scaling is useful for predictable workloads, for example, the weekly traffic of the retail company Amazon.com. Automatic scaling is also useful for dynamic, on-demand scaling. Amazon.com experiences a seasonal peak in traffic at the end of November on Black Friday and Cyber Monday, which are days when US retailers hold major sales. If Amazon provisions servers using fixed capacity to accommodate the highest use, 76% of the resources would be idle for most of the year. An autoscaling group is a collection of Amazon EC2 instances that are treated as a logical grouping. The size of the autoscaling group depends on the number of instances you configure as the desired capacity. You can adjust its size to meet the demand either manually or by using automatic scaling. You can specify the minimum number of instances in each autoscaling group, and Amazon EC2 Autoscaling will prevent your group from going below that size. You can specify the maximum number of instances in each autoscaling group, and Amazon EC2 Autoscaling will prevent your group from going above this limit. If you specify the desired capacity, either when you create the group or anytime afterwards, Amazon EC2 Autoscaling will adjust the size of your group so it has the specified number of instances. If you specify autoscaling policies, then Amazon EC2 Autoscaling can launch or terminate instances when you have the demand or the application increases or decreases. For example, the diagram shows that this autoscaling group has a minimum size of 1 instance, a desired capacity of 2 instances, and a maximum size of 4 instances. The scaling policies that you define adjust the number of instances within your minimum and maximum number of instances, based on the criteria that you specify. With Amazon EC2 Autoscaling, launching instances is referred to as scaling out, and terminating instances is referred to as scaling in. To launch EC2 instances, an autoscaling group uses a launch configuration, which is an instance configuration template. When you create a launch configuration, you specify what information instances will use when scaling. The information you specify includes the ID of the AMI, the instance type, IAM roles, one or more security groups, and any EBS volumes. Next, you specify where you want the scale. You define the minimum and maximum number of instances and desired capacity of your autoscaling group. Then, you launch it into a subnet within a VPC. Amazon EC2 Autoscaling integrates with Elastic Load Balancing to enable you to attach one or more load balancers to an existing autoscaling group. After you attach the load balancer, it automatically registers the instances in a group and distributes incoming traffic across those instances. Finally, you specify when you want to scale the event. You may have other options to consider when scaling. You can configure your autoscaling group to maintain a specified number of running instances at all times. You may want to maintain the current instance levels and Amazon EC2 autoscaling performs a periodic health check on running instances in an autoscaling group. When Amazon EC2 autoscaling finds an unhealthy instance, it terminates it, and that instance is replaced with a new one. If you choose manual scaling, you specify only the change in the maximum and minimum or desired capacity of your autoscaling group. With scheduled scaling, scaling actions are performed automatically as a function of date and time. This is useful for predictable workloads when you know exactly when to increase or decrease the number of instances in your group over a day, week, or month. You can configure dynamic on-demand scaling as a more advanced way to scale your resources, where you define parameters that control the scaling process using scaling policies. Scaling events for on-demand scaling can use Amazon CloudWatch to check for CPU utilization and only scale when your predefined threshold for CPU utilization is breached. This option is useful for scaling in response to changing conditions when you don't know when these conditions will change. Finally, you can use Amazon EC2 autoscaling with AWS scaling to implement predictive scaling where your capacity scales based on predicted demand. Predictive scaling uses data that is collected from your actual EC2 usage, and data is further informed by billions of data points that are drawn from our own observations. AWS then uses well-trained machine learning models to predict your expected traffic and EC2 usage, including daily and weekly patterns. This model needs at least a day of historical data to start making predictions and is re-evaluated every 24 hours to create a forecast for the next 48 hours. The prediction process produces a scaling plan that can drive one or more groups automatically for scaling EC2 instances. One common configuration for implementing dynamic scaling is to create a CloudWatch alarm that is based on performance information collected from your EC2 instances or load balancers. When a performance threshold is breached, a CloudWatch alarm triggers an automatic scaling event that either scales out or scales in EC2 instances in the autoscaling group. To understand how it works, consider the example. First, you create an Amazon CloudWatch alarm to monitor CPU utilization across your fleet of EC2 instances, and run automatic scaling policies if the average CPU utilization across the entire fleet goes above 60% for more than 5 minutes. Next, Amazon EC2 autoscaling adds a new EC2 instance into your autoscaling group based on the launch configuration that you created. After the new instance is added, Amazon EC2 autoscaling makes a call to the elastic load balancing to register the new EC2 instance in that autoscaling group. Finally, elastic load balancing performs the required health checks and starts distributing traffic to that instance. Elastic load balancing then routes traffic between EC2 instances and feeds metrics to Amazon CloudWatch. So far, you've learned about scaling EC2 instances with Amazon EC2 autoscaling. You also learned that you can use Amazon EC2 autoscaling with AWS autoscaling to perform predictive scaling. AWS autoscaling is a separate service that monitors your applications. It automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. The service provides a simple, powerful user interface that enables you to build scaling plans for resources such as Amazon EC2 instances and spot fleets, Amazon Elastic Container Services, Amazon DynamoDB tables and indexes, and Amazon Aurora replicas. If you're already using Amazon EC2 autoscaling to dynamically scale your EC2 instances, you can now use it with AWS autoscaling to scale additional resources for other AWS services. Thanks for watching. We'll see you in the next video.
It's now time to review the module and wrap up with a discussion of a practice certification exam question. In summary, you learned how to distribute traffic across Amazon EC2 instances using elastic load balancing. Identify how Amazon CloudWatch enables you to monitor AWS resources and applications in real time. You can explain how Amazon EC2 autoscaling launches and releases servers in response to workload changes. You can perform scaling and load balancing tasks to improve an architecture. Great work! Let's get a look at that sample certification question. Which service would you use to send alerts based on Amazon CloudWatch alarms? In this example, the keywords to recognize are send alerts and Amazon CloudWatch alarms. Based on the keywords that we identified, we can look at the correct answer as A, Amazon Simple Notification Service. When you create a CloudWatch alarm, you configure it to send a notification to an Amazon SNS topic. We are able to eliminate AWS CloudTrail because while you can configure CloudTrail to send notifications to SNS topics, the keywords are based on CloudWatch alarms. We can eliminate AWS Trusted Advisor, which is a service that looks at your AWS environment and provides real-time guidance to help you provision your resources according to best practices. Finally, we can eliminate Amazon Route 53, which is a DNS web service. Thanks for watching.